In this presentation, we recognize that roads are complex physical structures and that the geometric characteristics of the road influence the way traffic flows. Roads that are flat and wide and straight readily accommodate large volumes operating at high speeds. Roads that are steep and narrow and curvilinear tend to calm traffic and meter the rates of flow. A well-designed facility has geometric attributes that serve the purpose for which the facility was intended. The familiar phrase, form follows function, is evident in the classification of roads according to function. The traffic engineer should be familiar with highway classification systems and the main elements that define the geometry of a highway section. That would be horizontal alignment, vertical alignment, and cross-section. Here, I will introduce functional classification of roadways and address some of the pros and cons associated with traditional hierarchical classification. I will also discuss more recent themes, such as access management, complete streets, and traffic calming. Finally, I'll identify the basic elements of a cross-section and call out resources and tools for further investigation. Before I begin, let me answer the question, why do I care about functional classification, by pointing to select application. At the top, we find a table where the design vehicle for the intersection is identifiable in terms of the classifications of the intersecting roads. If we know that one of the intersecting roads is classified as and the other is classified as an avenue, then the design vehicle for the intersection can be identified as school bus, and the dimensions of the intersection can then be specified to accommodate the physical dimensions and turning capabilities of school buses. Thus, functional classification is used here to identify a suitable design vehicle for the intersection to accommodate. At the bottom, we find an engineering study of a particular segment classified here as principal arterial. The 3-year collision rate has been identified as 3.96 accidents per million vehicle miles of travel. The traffic engineer can compare this accident rate with the accident rates on other segments of principal arterial to determine if the 3.96 value is high or low compared to other segments in its class. Here, functional classification is used as a basis for comparative evaluation of accident rates. Traditional roadway classification is based on the hierarchical model of trip making, where the user begins the trip by exiting the land parcel, collecting with other vehicles in transitioning to a main movement, and the main movement brings him to his destination, where he then transitions from the main movement for distribution to finally enter the land parcel of his next activity. Local streets provide the access, arterials service the main movement, and collectors are part of the transition process. Roess et al. Provides Table 3.2 as a means of illustrating a typical classification system for rural and urban settings. We find freeways, arterials, collectors, locals, and subcategories within each. See, for example, that this scheme includes major and minor collectors, and notice that local roads are subdivided by land use: residential, commercial, and industrial. Note that this is a typical classification scheme and that the individual agencies are likely to have something similar but different. This figure is a street classification map for the city of San Luis Obispo. Existing and proposed streets are color-coded according to classification. This segment of Los Osos Valley Road is classified as an arterial. This section of Choro is classified as a residential collector. The Central Business District, also known as downtown San Luis Obispo, includes a combination of local roads for access to land plus arterials for servicing through traffic. This presents a challenge, as it may be less than ideal to have through traffic moving through the central business district. This classification scheme is supported by category descriptions, so that the characteristics of a given street type can be properly discerned and correctly associated with its class. Notice, for example, that this classification system includes a category called Parkway Arterial. This table gives the description. Parkway arterials are arterial streets with landscape medians and roadside areas, where the number of cross streets is limited and direct access from fronting properties is discouraged. The table includes associated standards for parkway arterials: 4 to 6 travel lanes, speeds no greater than 45 miles per hour, and level of service D or better. This table specifies standards for other types of streets. For local commercial streets, we find 2 travel lanes, speeds no greater than 25 miles an hour, and average daily traffic at no more than 5,000 vehicles. When volumes exceed these maximums, design and/or operational treatments are evaluated to mitigate the condition. Traffic engineers will aim for design and controls appropriate to the intended function of a facility. Where roads of different classification intersect, trade-offs are made to accommodate a multitude of needs. In this depiction of a typical open grid system, we find a number of places where local roads intersect with arterials. Take a moment to identify these local meets arterial intersections. The adjacent figure depicts a typical subdivision where an effort has been made to isolate the local roads and prevent them from intersecting with arterials. The embedded video speaks on behalf of walkable urban design. Which of the 2 network styles here appears to be more walkable? So we recognize that the process of establishing a functional classification is an ongoing process. This link points to FHWA's Functional Classification Guidance Update, where we find that there continues to be a need for a rational classification system that promotes a sensible distribution of capacity and a cost-effective use of resources. We know that mobility and land access have been traditionally identified as the primary determinants of functional classification. Yet we find that the traditional hierarchical classification has been criticized as emphasizing speed over livability and the needs of the community. Some agencies are introducing greater flexibility based on context and multimodal needs. The classification system on the right illustrates what a more robust, multifaceted classification scheme might look like. The textbook has more to say about design and controls for servicing the intended function of arterials and local streets. Chapter 29 addresses themes such as access management, complete streets, traffic calming, roundabouts, and related network issues. 6 key principles from the chapter are given here. They are given in 2 sets of 3. On the left, we find signal cycle length in harmony with arterial signal spacing, median treatments that limit the number of conflict points, and controls on driveway number, placement, and design. In a moment, we'll look at supporting exhibits for these 3. On the right, we find calming treatments that reduce volumes and/or speeds on local streets. Broader focus and attention to modes other than the automobile. Intersection controls that reduce the number of conflict points. Let's take a closer look. Here we find greater signal density is associated with longer travel times. We also find that lower accident rates are associated with more restrictive median treatments and lower driveway densities. Take a few moments to consider these exhibits and to independently inspect the table and figures identified here. Consider these questions. What are the pros and cons of converting two-way stop-controlled intersections into signalized intersections? What are the considerations associated with installing a raised median? What are the trade-offs associated with concentrating flows into fewer driveways? This next slide has select exhibits dealing with traffic calming, complete streets, and roundabouts. Take a few moments to examine these exhibits and to independently inspect the figures and table identified here. Consider the following questions. What do you think about the various traffic calming treatments? What does it take to complete a street? What are the pros and cons of roundabouts? Traffic engineers aim to fit the cross-section to the function of the roadway. A menu of cross-section elements is given here. The menu includes median, shoulders, lanes for vehicles, bike and ped facilities, utility and landscape, drainage channels and side slopes, and clear zones. Choices from the menu must fit the function, the space, and the budget. Take a close look at the cross-section given for this 4-lane divided roadway. Which menu items are represented here? Which cross-section elements are properly identified on the drawing? Which cross-section elements are not properly identified? This website includes a link to FHWA's publication, Flexibility in Highway Design, which is motivated by context-sensitive solutions. Follow this URL or search FHWA Flexibility in Highway Design to locate the PDF. Launch the PDF and read about context sensitivity. Browse to Chapter 6, which is on cross-sections. Learn about the difference between the traveled way and the roadway, the various functions of medians, different shoulder treatments, clear zones, curbs, sidewalks, bike facilities, and more. Here we are reminded to balance the mobility and access needs of all users with the physical constraints of the right-of-way and the characteristics of the setting, and to also acknowledge the financial aspects of the project. Take a moment to examine the exhibit and read through the list of considerations. The exhibit is from Washington State DOT and it gives typical per-mile costs for right-of-way, $1.3 million per mile, as well as per-mile costs for individual elements within the right-of-way, like sidewalk, landscape, and utilities. In preparing to move forward into capacity analysis, it's important to recognize that capacity analysis is sensitive to such geometric properties, including the number and width of lanes, the presence of medians and shoulders, and the amount of lateral clearance. Studies show that free flow speeds are affected by these cross-sectional elements. Proper use of analytical methods will require knowledge of cross-sectional features. Let me take this opportunity to mention that StreetMix has an online visualization tool that allows designers and amateurs to explore options. The tool works like a digital soundboard, allowing the user to pop in a bike lane, insert landscaping, add a bus lane, or widen the sidewalks. In closing, let's recall that the functional classification of roadways has been shown to inform a wide range of decisions, including standards for design and level of service, capacity analysis, safety audits, and the selection of a suitable design vehicle leading to an appropriate choice for an intersection curb return.